So Math Minute 15, please make sure you're making corrections. So for number 1, you were rounding to the nearest thousand. Was it closer to 6,000 or 7,000? 6,000 or 7,000? 7,000. Number 2, you were circling the digit in the tenth place. The tenth place. Well, if you don't know your place values, where can you go for that? Where can you go for that? Evan. If you don't know your place values, where can you go to get help with that? Eduardo. In your binder, you have place values. Where else could you go for that? Finley. Right up there are place values. Yep. What digit was in the 10th place? What digit was in the 10th place? The 4 was in the tens place. What was in the 10th place? The 9 was in the 10th place. Number 3, 50 divided by 5 equals what? Equals what? 10. Number 4, what do we call the answer to a subtraction problem? What do we call the answer to a subtraction problem? Not quite, not quite. The difference, the difference, the difference. What is the difference in number 4? The difference in number 4. Not quite, not quite. You were close.
8,989.
And you have an and in there. Oh, let's say it without an and.
8,989.
Yes, 8,989. Number 5, how many inches are in a foot? How many inches are in a foot? Kaylin.
48 inches.
There are not 48 inches in a foot. How many inches are in 1 foot, Kaylin? 12. So how do we figure out how many inches are in 4 feet? 12 times 4, which gives us 48. So our answer is 48. Okay? Number 6. At what point did we know that we would use the less than symbol? At what point do we know we use the less than symbol? Zachary.
If this side is smaller and this side is bigger.
But on this problem, when did we know it was going to be less than? Lane.
It's better than the 8.
And what place value are they in? The hundredths place. Good. 700 is less than 800. Okay? Number 7, we should be looking for groups of what? Groups of what? Kaylin. 10. Are there any groups of 10 here? Adam.
8 and 2.
8 and 2 is one group. Are there any other groups of 10 here?
6 and 4.
6 and 4. So there's 2 groups of 10. That leaves another 5 to add on, which gives us 25. 25. Number 8. What's the name of that solid? The name of that solid. Audra. It's a sphere. It's a sphere. Number 9. What pattern do you see happening there? What pattern, Zach?
The same number is adding up each time.
The same number is adding up each time. Can you describe that a little bit more for us?
2 plus 2 is 4. And then it goes 4 plus 4.
Okay, so the previous number is being added each time, all right? Anybody see any other patterns? Mallory?
They're being multiplied by 2.
They're being multiplied by 2. Can you explain what you're saying there?
So 2 times 2 is 4. 4 times 2 is 8. 16 times 2 is 22.
So the previous number is being multiplied by 2, okay? So what would our next 3 numbers be then? Next 3 numbers. Mallory?
32, 4, and 128.
There you go. There you go. Number 10. Is that an example of the associative property? How many of you had true? good, it is. It's an example of the associated property. Please get that recorded and put away. On page 47, you have problems 4 through 9. 4 through 9. You were to do an estimate first, and then you were to do the actual, and we talked about the different methods. I took a quick look at those as I went around. On number 4, your estimate would have been 20 times 70, which is 1,400. The actual would have been 1,541. Number 5, 300 times 30 would give you 9,000. The actual, 8,961. Number 6, 600 times 90 would give you 54,000 for the estimate. The actual being 53,244. What questions do you have for me on those three? Estimate was 1,400. The actual 1,541. Mallory.
I found my multiplication for number 4.
You what?
I found the multiplication.
Okay. All right. Any question on how to do 4, 5, or 6? Number 7. Because there were 48 boxes and each box contained 24 cans, it was a repeat in there. We could repeat addition, or we could use multiplication, which by 6th grade, if it's repeat addition, we're going to use multiplication. You should come up with 1,152 cans. Label is important because it was a story problem. So 1,152 cans. Number 8. If every driver paid $25, and then it's a repeat of that $25, so we're going to multiply that 135 by 25, and you get $3,375. $3,375. Any questions on 7 or 8? Then number 9, you were doing your own multiplication there. I checked to see if you had one written down. There could be a variety of answers there. Are there any questions on that one? You had an option of which method to use. Any questions on that? Evan, you have a question? Okay. Today we're going to practice some more with our multiplication. I'm going to show you a third method of things that you can do that are going to match up with the box and the algorithm that we worked on yesterday. It's kind of a go-between that will show you the a third way that might help you understand it as well. I'll pass out the worksheet. Those of you at home, you can bring up the multiplication practice worksheet from Google Classroom. we've looked at two different ways we can show our multiplication. We can use that box method. We can use that algorithm. I'm going to show you a third one today, but I'm going to show it to you in relationship with the same problem. So we'll take the same problem, we'll do it three different ways, if that will ever pop up. Which I don't have to have that. All right. Let's see about line, well, no, just turn your paper over. You can use the back. Use the back. That way you've got notes all on the same page. Okay? All right. So let's take a look at, I think it was an easy one to start with. Let's take a look at number 8. We're going to do number 8. All right? That'll be one of the easier ones to start with. So on the back, you need to list that it's number 8. List that it's number 8. Okay? We're going to do 59 times 43. Okay? We're going to do it three different ways. We're going to come up with the same answer all three ways. Does that make sense? Okay? First way we're going to do it is the box method. Right? Okay. Oh. We're going to multiply 59 by 43, right? Okay? Yes, no? Familiar? Okay? Now, what we did the other day was we added yet another row because in the bottom row we did a what? A sum. Okay? Notice we can always add on to our table whatever we need. There's no magic to, we have to stop our table. We can always add on to it. Okay? So in our first box, the 5 has the value of what? The 4 has the value of what? In our second box, the 5 has the value of what? The 3 has the value of what? Okay, are we good so far? Any questions? I'm going to come over here. Do any of you over here have questions? Anybody over here? Because I got responses over here. I didn't get responses over here. Do any of you over here have questions? Okay? All right. The 9 has a value of what? 9. The 4 has a value of what? 4. The 9 has a value of what? 9. The 3 has a value of what? 3. Now, I'm going to change, yes, Caleb.
Are we doing it a different way? Because if one is 40 times 3, oh, okay.
By the community property, yes. You could do what now? This is 4 and 3 here, so we don't multiply those two together. Okay? Okay? Now, I would switch colors. I would switch colors. What's 50 times 40? Well, what's 5 times 4? 20 times 10 times 10? What's 50 times 3? Huh? What's 9 times 40? What's 9 times 3? Is there any question on where my numbers in black came from? Anybody? Anybody? And now my sum. Okay, are you ready? 2,000 plus 150 is 2,150. $360 plus 27. 387. Right? And now we need to add these two together. And I get 2,537. That's by my box method, right? Okay. Are we good with that? Any questions on how to use the box method? Okay. I'm going to show you another method. This is a method I did not show you yesterday. Okay? I think it'll be easy for you because if you understand the box method, this should be easy for you. Okay? What's 3 times 9? 27. Okay? Which is this right here, right? What's 3 times 50? Which was this right here. Yeah? Okay? This came from 3 times 9, right? This came from 3 times 50. If you want to make notes out to the side so you know where it came from, when you go back and look at it, you know where it came from. Does that make sense? Okay? So now I use that my 3, right? Well, this isn't 4, this is 40, right? What's 40 times 9? 360. That was my 40 times 9, right? Did I have a 40 times 9? Okay? And now 40 times 50 is 2,000. And now I add them all up. $2,537, right? Okay? So it's writing out each of the pieces essentially from the box method, right? Okay? All right? Now again, your parents probably never did this method. Okay? And here is what your parents get. Right here. We're going to do it right here. Okay? 9 times 3 is 27. We put the 7 down, and we carry the 2 into the tens column, right? Because we can't put 2 digits in the same spot, right? So we have to carry it over. 3 times 5 is 15, plus 2 more is 17. Well, now we're multiplying by 4, but it's in the tens place, so it's 40. So in order to get it in the tens place, we have to put that 0 there to get it over in the tens place, right? Okay? Some of you aren't writing. I'm not sure why. We've used up the 2, we've used up the 3, so please cross those out so we don't confuse ourselves. Okay? This is actually 40 times 9, but 4 times 9 is 36. I don't have room for a 36 in there because I'm going to carry my 3. 4 times 5 is 20, plus 3 is 28. I add them together. 7 and 0 is 7 and 6 is 18. 1 and 3 is 5. So all 3 ways gives us the same product. Okay? All right? Questions on any of this method? Yeah.
Are we allowed to do that one way that you just did?
You're going to practice all 3 ways. Okay? Questions? Does this one make sense?
Yeah.
Okay. Is this one clear to you? How about this one? Okay. This one is more, I know what process I'm just kind of winging myself through. These 2, you're clearly showing where your values are coming from. This one is kind of like, oh, I know, I just follow these processes. And you're not really understanding where it's coming from. You're just,
Be ready for Ms. Kaufman's homeroom class to get the picture taken in the STEM room. Thank
does that
you.
make sense? These 2 are a better understanding of where it's coming from. Okay? Yes.
Would it be easier to like put the distance on the side first? Would it be easier to put the distance on the side first and do the answer?
You can. You can. Anything else? Okay. That's all there is for today. We just did it. Okay, here's what we do. We reach a point of, if we keep cramming too much new into you, we might as well do nothing because the brain is too full, you know. All it's doing is spilling out and nothing's staying in. Okay? So we take a look at this worksheet. We're going to circle some problems that I want you to have done. All right? We just did number 8, so circle it. We already did number 8. Okay? I would like for you to do, and listen carefully, I would like for you to do number 1. And oh my, it's a 3-digit times a 2-digit. Ramps it up a little bit, doesn't it? Okay? So circle number 1. And I would like for you to do number 3. And it's a 2-digit times a 1-digit. It takes it down a notch. Okay? And then I would like for you to do number 4. Okay? All right? Now, if you turn your page over, there should be plenty of room on the back. And if there's not, like if you write big and there's not room, then you get out a piece of your lined paper and you use your lined paper. But here's what I don't want. Here's what I don't want. And Peyton, I'm going to use your paper unless you're going to be totally embarrassed that I talk about your paper. Are you going to be totally embarrassed I talk about your paper? Huh? Are you going to be totally embarrassed I talk about your writing? Okay. So you're good with it? Correct. So when I look at Peyton's paper, I see that Peyton writes real big here. Okay? And that's how Peyton writes. I've seen other papers that write even bigger, and like I've taken up this whole page for this, okay? Now, Peyton is going to need to use lined paper because Peyton won't possibly be able to get 3 more problems on here. You can see that from a distance that Peyton won't get 3 more problems on here. Here's what I don't want Peyton doing, or any of the rest of you who write like this. I don't want Peyton doing puzzle pieces to get his problems in. Here's what some of you do. You draw lines and you like make a puzzle out of it and try to scrunch things in. No. No, 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 no. Just draw a line here and start a new problem. He's probably going to get 2 problems on this page, and that's it. The practice one and a new one. Now, if I were him, I would just start a whole new page in lines and be done with it. Okay? Cindy, may I use your paper, or you prefer I don't? Okay? Now, when I look at Finley's page, okay, Finley took up only that amount of space. We can easily see she only took up that amount of space. Finley will probably be able to get 3 more problems on her page. Okay? That make sense? So Finley can probably just use the back of her page. All right? But Cindy may decide that she prefers lined paper as opposed to a blank page, and that lined paper is easy for her to work on. So Cindy might decide, I really want to get out lined paper, Mrs. Allen. I hate blank paper, and trying to do things maybe on blank paper. All right? So you need to make a choice that's good for you. But here's what I'm not going to accept from you is garbage work all over the place, and Mrs. Allen trying to figure out a puzzle on your paper. Does that make sense? You clear on that, folks? Dante, you have a question for me.
Which numbers are we supposed to do again?
You are to do 1, 3, and 4. 1, 3, and 4. And I want you to practice all 3 methods on those 3 problems. Okay? Yes. All 3 methods for all 3 problems. See how I did all 3 methods here? I want you to do all 3 methods for all 3 problems. Don't roll your eyes at me, honey. Don't roll. Because I'm doing it for your own good. Okay? Pretty harsh, huh? Mrs. Allen said I rolled out of lots of times. I raised children. I've had lots of kids in the classroom. Rolling eyes at me to sit up with. Now I catch it. Yeah, you can get standing. Now, keep in mind, folks, all your Friday work is due in. So if you don't have your Friday work done, you better get it done and turned in now. And then you work on this. But if you've already done your homework, ahead of time, you've used your time wisely throughout the week, you've turned in all your Friday stuff, then guess what? You're going to get this done and have absolutely nothing to take home over the weekend, because that's the way Mrs. Allen planned the week. And you would have no assignments for the weekend. But if you mismanage your time over the week, you'll probably have a few things to take home. All right? So, please use your time wisely. You've got time to ask questions.